Presentation in Unit 1. It's entitled As the Crow Flies. It says, a rooster crows only when it sees the light. Put him in the dark and he'll never crow. I've seen the light and I'm crowing. It's a famous quote by Muhammad Ali. So the learning goals for this presentation are that you should be able to differentiate between distance and displacement. Distance is generally thought of as the distance as you go for, or the length as you go from point to point, but that's not actually the case. A distance implies the entire path taken, and we'll get into that in a little bit more later. And that you'll be able to convert between the different metric units of length. So here's what you should already know. From previous classes, you should know that laboratory investigations require measurement. Measurement is the hallmark of any sort of science course. Okay, if you can't measure it, it's not going to be science. Now, science also requires a couple of other things, but it has to have some sort of measurement. You should also know that length can be measured with a ruler, or more specifically a meter stick. That's the one we're going to be focused in here, because we don't want to deal with inches. Inches is what you're used to, but that's not a good unit of measure. We want to use the standard unit of measure, or the meter stick. You should also know that values can be changed from one unit to another. For example, 3 feet is equal to 1 yard. Here's what you learned in the lab. That length can be measured in two different ways. We learned about distance and displacement. We learned that there are situations in which they can have the same value. For example, if I start here and I stop here, and I go straight from one point to another, the distance and displacement are equal because there was no change in direction. We also learned that distance and displacement can have different values if there's a change in direction. Length. Length is a fundamental unit of measure, which means it's something that can be measured independent of anything else. It doesn't depend on anything else. It is defined as the space, or the length, between 2 points. Okay, that has a standard unit of the meter, which you see in the meter stick. That's how it was originally defined in terms of a standard meter bar, but that wasn't good enough, so they actually came up with a definition that is how far light will travel in this time. So it's 1,299,972,458th of a second. Next, you have distance. Distance is defined as a lowercase d. It's a scalar. Now, a scalar is a really important value because what that means is it's defined as a number only. That means it is a number only. There's no direction associated with it. It's not 10 miles east. That's no longer a distance. It is defined as the total length traveled between 2 points. So if I start here and I stop here, if I had to take this line and I had to stretch it all the way out, that would be the total distance traveled. If you were to look at your odometer on your car, you have an odometer, O-D-O-M-E-T-E-R. If you have an odometer, that right there tells you the total distance traveled. It's measured with a meter stick or a metric ruler. The standard unit, which is what we're interested in, is in the meter. Now, you can also see it in miles, kilometers, and feet, but we're interested in the standard unit of the meter. Okay, it says which of the following is a property of distance. Mark all that apply. So you should know that it is a scalar. You should know that it is measurement of length. You can measure it with a meter stick. The standard unit is not the kilometer, instead it's the meter, and that it's represented with a lowercase d. Okay, it says write a sentence describing how you could measure the distance between your first and second period classes. Use 3 to 5 terms from your academic vocabulary. That's going to, of course, depend on your use of the words, but you could say, here's my first period class, here's my second period class, and what I would do is I would say there's a certain pathway that I have to go, so I have to go from here to here to here, and then back down this hallway because there's nothing here. This is no man's land. So if I was trying to find the total length traveled, which is what we have for distance, I would have to lie down a metric ruler and measure the length between these points, the length between these points, the length between these points, the length here, and the length here, and you would have to add them all together. So that's how you find the total distance, or excuse me, the distance is by finding the total length that you walk to go from your first period and your second period class. An interesting thing about distance is it can change depending on the path that you take. Say, for example, that this is a shortcut, and you could cut straight through here. We'll change the color. If you cut through here, that changes the distance. The distance is now this length here, as opposed to our previous length. So distance can change. Next, it says a student is looking at different routes from the University Station to the Tai Pao Market Station. It says the walking path is marked in black, which correctly demonstrates the distance a walker would travel. So this right here is the starting point. This right here is the ending point. And you have two different points marked. You have point A and you have point B. Point A represents the path that the walker can travel. So it's kind of a winding path. You can assume it's following a road. That would represent the distance. That's the total length traveled. It's what you actually walk. This B term is the shortest distance between the points. That ends up being displacement, and we'll talk a little bit more about that in just a minute. It says a woman walks 2 blocks north. Okay, so she starts right here. She walks 2 blocks north. Okay, and then she turns and walks 5 blocks east. So 1, 2, 3, 4, 5, and my drawing's not going to be great to scale because I'm going to run out of room here. And then she turns and heads 8 blocks south. 1, 2, 3, 4, 5, 6, 7, 8. So this right here represents 8 blocks south. This represents 5 blocks east, and this represents 2 blocks north. And if we're trying to find the total distance, you would say it's 2 plus 5 plus 8, which gives us a total of 15 blocks. Next, we have displacement. Displacement is a little bit different than distance in that displacement is a vector. A lot of times you'll see it as delta D, or sometimes delta X or delta Y, depending on the book. What that means is it means the change in position, or what is the shortest length between the start and the stop point. Whenever you're talking about displacement, you're no longer interested in the path that's taken. You're saying, where did I start? Where did I stop? What's the shortest distance between those points, or what's the shortest length between those points? Now, distance and displacement have a lot in common. They're both measurements of length, and they both are measured with a meter stick or a metric ruler. They both have the same standard unit of the meter, so there's a lot in common. In fact, a lot of times people use distance when they actually mean displacement. Distance is a common vernacular. It's a word you hear in every day, whereas displacement is not. Now, what makes displacement a vector is because you don't have to worry about this entire path and changing directions. It makes it a vector, which means it has a number, which remember we called a magnitude, and it also has a direction. So if you have something that's a